Hey kids, welcome back to Smith Motorworks. Working on the old Sears again. We'll get that flywheel off of there, check out what's going on underneath, and we'll do a little bit of a review on a puller set that I bought off Amazon. See if it's something that you could use for your projects. Let's check it out. And one thing that happened with the comments, which is wonderful, please comment. Tell me if you don't agree with what I'm doing. Tell me if you got something like this. Ask me questions. Maybe I can get you the answer, whatever. But I got a really good comment, and I want to mention that. Somebody had posted that, yeah, he doesn't know what he's talking about because there's a light that powers the tail light on this, and it has to be working before the engine will run. And I should have read the manual that I was bragging about. Well, hey, that's fair. I should have read the manual, and I did, because that's exactly right. And what this commenter did not see was the fact that I had grounded that wire. Now, why does any of this make any sense and relevant to what we're doing? As I mentioned before, that magneto, that is the power source for everything on the bike. There's no charging system, there's no battery, there's nothing. It runs completely off of the cool fact that if you run a magnet through a coil, past a coil of wire, it generates electricity. It's the opposite of how an electric motor works. Pretty cool. I'm a mechanical engineer or engineering tech, so the sparky stuff, I know a tiny bit about it, but DC circuitry, I can usually figure that out. What's going on here is one of those coils that we saw on the breaker plate that powers the tail light. Now it needs to go to ground to do that, so one of two things happen because the tail light isn't on all the time. So it goes to a switch, which is sadly absent on this old girl, and the switch is grounded. So that power wire is grounded. When you hit the brake pedal, the switch goes from ground over to brake light, lights the bulb up, and that goes to ground. If you don't have a bulb in there, or the bulb filament's broken, or the wire's broken from on that side, when you hit that brake pedal and it goes from grounded to trying to power that bulb, the engine will die. So I don't have a brake light switch. I don't have a tail light bulb in here. I looked at the wiring diagram. We'll take a look at that in a second and see why this actually works and makes sense. But I said, I'll just ground that wire and that will make it work. Well, it should have made it work, but there's other problems that we're going to dig into here. But great comment. Good chance for a what's called a teachable moment. My wife's a teacher. I teach basic motorsports fabrication at a community college. And when you get an opportunity like that, you got to take it. And that's why it works. So look at the wiring diagram, get your head around that, and you can figure it out.
Okay, here's a close-up of the wiring diagram showing the magneto and the breaker plate and the green wire that I was just talking about. When you're not pushing the brake pedal, it's going to ground, and when you do, it's rerouted through the 15-watt side of the bulb here and then to ground. So you can see if this bulb's missing or filament's broken or this wire is broken, you push the brake pedal, now you've created an open circuit and the motor stalls, which is exactly outlined right below the wiring section. So if you push the brake pedal and the engine stops, you replace the bulb or you fix the wire, just like I said, or you do what I did and just ground that wire, so it's like you've never pushed the brake pedal.
Okay, this is actually already loose, but I wanted to show you how these things work. in case you've never used one. They are marked with the size in this particular case. Let me see that or not. It's M19 by 1. That's the major diameter of the thread and the thread pitch. So if you want to learn more about that, it's all over the web, but it's basically 19 millimeters on, at least on metric stuff. That's how big this outer size is. And one full turn takes a millimeter. So 360 degrees, it moves in or out 1 millimeter. None of that really matters for this other than getting the right one. I mean, you can't use the wrong thread or it won't come out. If you saw on the previous episodes, if you go back and watch those, I had a couple pullers and they didn't fit for other motorcycles. It's kind of standardized, but kind of not. I think some companies preferred a certain size and some parts of the world prefer a certain size. It seems like this is pretty popular with Italian stuff, which this little bike is. But hey, it could be anything. You just got to get the right one. Now, this is filthy inside of here, or was. So you want to make sure that's really clean because, again, this is fine thread and this is hardened and probably this is too, but you get a bunch of crap in there, it tends to tear up the threads and you don't want to do that. You're trying to fix it, not break it. But basically, what's happening with these things, if you don't know, and a lot of you do, but I'm going to show it for those that don't. It's a pretty long pull there, but this is basically like a piece of pipe, and it has threads on the outside. There's threads on the inside of this, and that's what you're turning this in here like a handle, basically, to grab onto those. You can see it threading in there. I mean, get it in there as far as it'll go. I mean, you don't want to force it or break it, but good rule of thumb for thread engagement is the diameter. So 19 millimeters. If you can go in 19 millimeters, that's like, what, 3/4 of an inch or something. If you can get it in that far, you're golden. All right, this right here, this outside thread that goes into that's really just arbitrary. The important part is, if you can see on the end here, it has a little point on the end of it, because that fits into the end of the crankshaft. It keeps from mushrooming that head. But I cranked this big thing off of here, but it gotta run it back down here. Probably longer than it needs to be, but what's happening is I'm turning that in and it's going against the crankshaft of this. And when it hits that, and you can hold this out here with a wrench or something and put another wrench on it. I just put my little fancy homemade puller on here just to keep it from turning, so I could do it with one wrench. But basically it's pushing that, and it's probably really difficult to see, but it's slowly pushing against the crankshaft, grabbing onto this outer piece here and pulling it away. So, ta-da, there you go. It's off of there. So you can see the advanced mechanism inside of that, the magnets that are actually generating the power to run this thing and run everything on it, actually. Looking a little closer here and see the actual breaker plate with the coils. The points are down in here. We'll dig into that in a minute. Hey, here's a little flywheel puller set I bought to use on the Sears to remove that flywheel since I didn't have the right size. It didn't come this way. You got to customize it. Got to be different. Make it some Smith Motorworks, branding on there. I don't remember what it said. It had part number and some bogus, seal of quality or something. This is, a Chinese import tool. Unfortunately, I really couldn't find one that was, a quality tool, I would say. But, these are okay. They're getting better. Let's take a look inside of this thing. Turn it around. Nothing too trick about it. I mean, any of the sets would probably be like this, you know, blow molded case, little kind of chintzy latches on here. This, I don't even remember what brand this is. I'll post the link below, but I'll tell you, there's like 4 different ones that all looked exactly like this. Some of them had like a black case, some of them had a red case, some of them had a blue case. It was all the same stuff. Probably all came out of the same factory, and they're just putting different names on it. I don't remember. This was like Moto Pro or something wacky like that. But again, I already cut it up. If you can see here, I cut some pockets in this for the 2. If you look at the previous videos, the 2 that I had that I was hoping would work, I put them in here. It's a good set. I mean, there's a whole bunch of sizes. And the kind of the cool thing that they have on a lot of these is there's 2 threads on each puller. Like there's a thread on this end and a thread on that end, and you just turn this puller bolt around. You thread it in on the other side, and it works for both sizes. So these, you can see that or not? It'll focus. Get it flipped around here. Yeah, it's got the size on there. Like I was saying earlier, I mean the size is kind of arbitrary. I mean, it doesn't mean anything unless you know that from your manual what your machine needs, what it requires to pull it off of there. But I think I might actually get the label maker out, and good fit in there. Gets in there, ain't coming out. I might get the label maker and put it on the side here, because I got a feeling that those markings are going to wear off over time. Maybe not. And again, like I said, the number doesn't matter. It's does it fit or not? And you know, you obviously wouldn't want to be jamming something in there that didn't fit, because now you got a new problem. But I would recommend this. I mean, it was like $30. I think the blue cost me like $2 more than the red, but I got a bunch of red stuff and I wanted it to stand out. And I thought, you know, it looks cooler with, you know, the decal that I made on here. But it really doesn't matter. They're all kind of the same. I was gonna try to make one or buy one or something, you know, because I'm like, hey, I knew what thread size that I needed, but M19 by 1, it turns out to be kind of a non-standard size. I got a lathe, I could cut that thread, but you start, like I've talked about before, the whole make versus buy proposition. Nobody works for free, and you know, I gotta cut up some of my materials. I gotta spend my time setting all this up, and you know, I got it set up for cutting standard threads on my lathe, so I gotta change the back gears in it, and it's just like, man, dude, I want to spend like 4 hours to make this, and it would be cool because it would be one of one, it would be mine, but I decided to feed the beast and bought this thing. So if you need one of these, I would recommend it. $30. Hey, you know, that ain't free, but it's pretty cheap for all the stuff that you get. And if you got some buddies that are working on, you know, small engines, motorcycles, whatever, and we all do, right? You know, you loan your tools out to somebody you trust, you get them back, that's all good. You help each other out. They'll help you when you need something, right? One last thing I wanted to show you here. You know, I mentioned that I cut a pocket in here for my kind of lone wolf, you know, random ones that I probably have duplicated here in another side. I'll figure out what these are, but I don't remember. Like I said, I think one of them I bought for Husqvarna, and the other one is for Kawasaki H1 that I have. But you know, this blow molded stuff, I believe this is the same kind of plastic that a milk jug is, which is a HDPE. I think that's like high density polyethylene or something like that. I don't know. You can correct me in the comments, but the cool thing about that plastic, I mean, there's really 2 kinds of plastic. There's thermoplastic and there's thermoset. Thermoplastic, that's the recyclable stuff. You just keep grinding it up, melting it, going over and over and over again, you know, until the end of time. The thermoset stuff, not so much. You know, you can't do anything with it after you've molded it or shaped it. But the thermoplastic stuff's pretty neat. So I took my soldering iron, which had a plastic cutting tip, but you could use a soldering iron or a box knife. Be careful. But you could, I hacked this thing out of here, and I didn't really care how smooth it looked. But I took a piece of the patch out of here and bent it, put like an offset in it, and melted it back together, and then melted it down to the bottom, because this one would fall down in there and it made it harder to get out. But now it just pops in this little pocket. This one over here, I didn't have to do that. I just cut a hole in there, and it's not as easy to grab as the factory pocket, but it's in the case. They're all together. I don't have a separate little box where I'm like, well, heck, where is that one? I mean, you got to flip the garage to find it. They're all together here, and you can customize these things and put whatever you want. I mean, and use a scrap or use the same kind of plastic and just melt it back together. And I did kind of like sand that off a little bit, but if you're really, really detail oriented, you can make it really pretty and smooth it out. They make little smoothing tips for soldering irons to slick this stuff up. So it's plastic welding, I guess, but pretty easy. Dare to be different. Make it your way. Make it work for you. Hey guys, we're going to stop it right there this time. Put another one in the can. Had a friend come by. Need to use a lathe for a little bit. Got some work done. We're going to get back on the Sears though, but I want to take my time on that breaker plate so we don't tear anything up, because it's old wiring, fragile, stuff like that. Probably not replaceable either. So definitely stay tuned, because there's going to be more of that coming. Do your homework though. As always, like, subscribe, share. Please subscribe. I see like 80% of the viewers are not subscribers. It doesn't cost anything, and it helps me out. Keeps me making videos. Obviously, you're liking it if you're watching it, so appreciate it. Click that button. Become a subscriber. It's not going to pester you or anything. It just lets you know when I make new stuff, which I try to do every week. Maybe a little shorts, a few short videos here and there in between on top of that. But we'll be back. So tune in again. Later.